at the questions from the homework, and we're looking at Chapter 3, Section 1, Question 41. So I'll put 3.1.41. Now remember, our numbers might be different as these are generated randomly. So I have 4 minus 9x minus 3x squared. So 4 minus 9x minus 3x squared. And we want to write this in vertex form. So we want our function to have some constant a times x minus h squared plus k. So our goal is going to be to complete the square. So the first thing I'm going to do is I'm going to take this version of the function and I'm going to write it in descending order. So I'm going to put the negative 3x squared out front, minus 9x plus 4. And I'm going to focus on just the terms with the x, because I want to focus just on these terms, and I want to pull a negative 3 out. Give some space over to the 4 so I can work here. Now, let's convince ourselves this works. If I multiply this negative 3 back through the parentheses, I get negative 3x squared minus 9x plus 4. I get my previous line. So the step I'm doing is justified. It's reversible. I can get to where I started from. Now I want to complete the square on the inside. So I half this and square it. And so half of this is 3 halves, and if I square that, I get 9/4. But I can't change the value of what's in there, so I have to add the 9/4 and subtract the 9/4 at the same time. Right? That's the nature of the beast with completing the square. Is I want the perfect square, but I can't add a number to my expression or I'll change its value. So I have to add 0. And I'm adding 0 here, right? 9/4 minus 9/4 is 0. I'm adding 0. What I'm going to do is I'm going to get this bit outside. So my negative 9/4 has to come out. So I'm going to have my negative 3x, I'm going to have my x squared plus 3x plus 9/4 inside my parenthesis. Now when this 9/4 comes out, it has to go through this coefficient in front. Right? This negative 3 is multiplying by everything in there. So if this is coming away, I have to do a minus times a minus is positive, and 3 times 9/4 is 27/4. Well, I've forced this bit to be a perfect square, which was the 3 halves squared. And then this bit outside I have to take care of. So plus 27/4. Well, if I write 4 as fourths, it's 16/4. And so I get negative 3 x plus 3 halves squared plus 43/4. So I'm looking at the practice exam, and I'm looking at question 24. It says a carpenter is building a rectangular room with a fixed perimeter. So I have a rectangular room where the total perimeter is equal to 324 feet. What dimensions would realize the maximum area? So we'll have a length times a width. So one of the things we have to do here is we're only doing functions in one variable, and this has 2 variables for us, length and width. So we have to take the perimeter equation and solve it for one of the variables. So since we know our total perimeter is 324 feet, we'll take 324 2L plus 2W. Well, these both have a factor of 2. So I'll factor that out. I'll divide both sides by 2. So 324 divided by 2 is 162. And I'm going to pick one of these variables that I am going to replace. And I think I'll I'll solve for W. So W is equal to 162 minus L. As I subtract L from both sides, I'll get W on its own. And so we now have the width in terms of L. Well, the area of a rectangle is L times W. So wherever we see W, we can replace this in. So I have L times 162 minus L. So I will factor the L through. 162 L minus L squared. And so my function of area as a area as a function of length is negative L squared plus 162. Well, it's going to maximize 162L at the vertex. So I will use my vertex equation to find the vertex. Now I have two options here. I can complete the square, or I can use the negative b over 2a. And I'm going to say, hey, my L value, when this is maximized, is going to be negative b over 2a, where my b is 162, and my 2a is negative 2, right? Because a is negative 1, and my b is 162. The negatives will cancel, and I get 81 feet. So my length is 81 feet. Come back and use what I have for W. 162 minus 81 was also 81 feet. And so if I maximize the area of this rectangle, my dimensions will be 81 feet by 81 feet. Or it's going to end up being a square of 81 feet. Maximization of a rectangle with nothing limiting one of the sides, like a building or anything. The area is always maximized for a fixed perimeter to a square. All right, so I'm going to look at problem 25 on the homework review. Or not the homework review, the test review for Chapter 3. So problem 25, I have, suppose the revenue R in thousands of dollars that a company receives from producing X thousand compact disc players is given by the formula. The function of R given X is equal to X times 60 minus 3X. And what we want to do is evaluate R of 3, which is what will be the value when we've sold 3,000 compact disc players. So we want the thousands of dollars. So when R of 3, I plop 3 into R, and we get 3 times 60 minus 3 times 3, which is 3 times 60 minus 9, by 3 times 51, which is 153. And so that means if they produce and sell 3,000 compact disc players, CD players, they take in revenue $153,000. And so our revenue function comes from that. How many CD players should they produce to maximize their revenue? And so maximizing, we're going to realize, hey, this function is quadratic. So I'm going to multiply the x through, and I'm going to write it in descending order. And we're going to realize that x is maximized. The maximal number when the x value, I'll put max for there, is negative b over 2a, which in this case is negative 60 over 2a is negative 6, or 10. And so they're saying that they should produce the maximum amount of CD players they should produce to maximize revenue they need to produce 10,000 CD players. And then so the last question is, well, what is the maximum revenue? Well, the maximum revenue happens when we produce those 10,000 CD players. And so I'll take 10 and I'll throw it into each of these parts of the function. So I'll put 10 into x and 10 into x. So I get 600 minus 300, or $300,000. And so the maximum revenue they can do for producing this product is $300,000 coming across. All right, so I'm going to look at problem 25 on the homework review, or not the homework review, the test review for Chapter 3. So problem 25, I have, suppose the revenue R in thousands of dollars that a company receives from producing X thousand compact disc players is given by the formula, function of R given X is equal to X times 60 minus